on 5.2 today. So, a factory that produces pistons for cars. At a factory that produces pistons for cars. Machine 1 produces 114 satisfactory pistons and 76 unsatisfactory. Machine 2 produces 166 good ones and 34 bad ones. Suppose that one piston from machine 1 and one piston from machine 2 are chosen at random. What is the probability that the piston chosen from 1 is unsatisfactory and the piston chosen from 2 is satisfactory? So what we do is we take the machine 1 answer and we multiply it by the machine 2 answer. Okay? So we want to know what is the probability that machine 1 piston is bad and the machine 2 piston is good. Well, what percentage of the ones are good? Or sorry, are bad? Well, it made 114 good ones and 76 bad ones. So 114 plus 76 is 190. So what's the chance you reach into the box and you pull out a bad piston? 76 out of 190. So 76 out of 190. Okay? And then with machine 2, we had 166 good ones and 134 bad ones. So machine 2 made 200 pistons. What's the chance that we reach into the box and we pull out a good piston? Would be 166 out of 200. Okay? Do you see that? We get this number by adding the good and the bad together. We get this number by adding the good and the bad together. And then this is the number of bad pistons, and this is the number of good pistons. And then you just multiply the two fractions, which is top times top divided by bottom times bottom. Or you could just do 76 divided 90 times 166 over 200. And I get 0.332. So the probability is 0.332, which means there is a 33% chance that you reach into box 1 and pull out a bad one, and then you reach into box 2 and you pull out a good one. A third of the time, that's what's going to happen. Okay. The other options would be you pull out good and good, or bad and bad, or good and bad. Yes. So if you want to know what is the probability that A happens and B happens, you multiply those together. Okay? All right. Do you want to see another one of those? No? Yes? Okay. A student ran out of time on a multiple choice exam and randomly guessed the answers to 2 problems. Each had 4 choices, A, B, C, D, and only 1 correct answer. What is the probability that she got both correct? So we have 2 guesses. Guess 1 and guess 2. And what is the chance of getting guess 1 correct? 1 out of 4. What is the chance of getting guess 2 correct? 1 out of 4. And so what is the chance of getting 1 correct and 2 correct? 1/16. Okay? What if I changed it and I said correct and incorrect? How would that change the answer? Right. The chance of getting 2 incorrect would be 3 out of 4. And then when you multiply, you get 3/16. Okay? So if you want to know what's the probability of this happening and this happening, you just multiply the answers together. Okay. An urn contains 7 black and 5 green balls. 4 are randomly drawn with replacement. Do you guys know what with replacement means? You draw, write down your result, and you stick it back in. Is that different than drawing and drawing and drawing and drawing? Oh yeah, very different. Right. And if you are drawing with replacement, how many balls can you draw out? Infinite. If you're drawing without replacement, how many can you draw? However many are in the bag, right? And the calculations end up being a little bit different. So we are going to draw 4 times. Okay. What is the probability that all 4 are black? Well, the first one, when I reach in, what's the chance of getting a black on the first one? 7 out of 12. And the next one? 7 out of 12. And 7 out of 12. And, wow, that was beautiful. 7 out of 12. So 7 to the 4th divided by 12 to the 4th. That's the percentage we're looking for. So 7 to the 4th divided by 12 to the 4th. And we're rounding to 3 decimal places. So I get 0.11578. When we round that to 3 decimal places, what do we get? Good. 0.116. All right. Okay. Let's do another one of these. A fair dice is rolled 4 times. What is the probability of having number 1 and number 2 among the rolls? Oh, having no 1 and no 2. Okay. Sorry, I thought that was number. So we're going to roll 4 times. Okay. What is the chance of getting no 1 or no 2? 1/3 or not 1/3. It's actually 2/3. Because it would be 4 out of 6. How many ways are there to not get a 1 or a 2? You would get a 3, a 4, a 5, or a 6. So it'd be 4 out of 6, which simplifies to be 2/3. Does that make sense? Oh, okay. Okay, and 4 out of 6, 4 out of 6, 4 out of 6. So this would be 4 to the 4th over 6 to the 4th. So 4 to the 4th divided by 6 to the 4th is 0.198. So 20% of the time, if you play this game, you will get no 1s and no 2s. Okay, this is called a two-way frequency table. So we are asking 2 questions. And when we ask those 2 questions, whatever response the people get, we stick those numbers in a particular box. So in total, there are 80 items. So you get to choose between sweatshirt or t-shirt and choose between parent or student. Okay. One thing that usually helps when you have a two-way table is to write the totals. So how many sweatshirts were sold total? 32. How many t-shirts were sold total? 48. And how many of the people were parents? 26. And how many were students? 54. And then notice, when I add those together, what do I get? 80. And when I add those together, what do I get? 80. Okay. So we have lots of questions. What is the probability of randomly picking a sweatshirt? So how many of the total items were sweatshirts? 32 out of, so this would be 32 out of 80. Write your answers as decimals. Okay? 32 out of 80. Okay? Now I'm gonna give you other questions because they don't have very many. What is the probability of student? So if we randomly pick one person, what is the chance that that person is a student? 54 out of 80. Okay? Does everybody understand that? Yeah, we'll get there. Okay? What is the probability of randomly picking a shirt, a t-shirt? So that would be 48 out of 80. Okay? All right, now let's make it a little bit harder. What is the probability that you randomly pick a person, and that is a student who bought a t-shirt? A student who bought a t-shirt. That would be 30 out of 80. Okay? What is the probability of randomly picking a person, and that person is a parent who bought a t-shirt? That would be 18 out of 80. Okay? Does everybody understand that? That's a single box. 18 out of 80. Okay? What is the probability of randomly picking a person, and that person is a student or a sweatshirt purchaser? This one's a little harder. You could do it that way. Yeah. So who are we talking about here? Who are these people? It's everybody in the sweatshirt column and everybody in the student row. So should I just add 32 and 54 together? No, why not? Because we would count the 24 twice. So if you add 32 and 54 together, like Bonnie said, then you would need to subtract 24. That would work. So you could do 32 plus 54 and then subtract 24, and I get 62. How else could you do that? You could add all of those together. 8 plus 24 plus 30 is 62 out of 80. Okay? So does everybody understand the and the or? And would be the one box that is in that row and that column. Or would be everything in the row and everything in the column. Okay? Now, what does this mean? This means, what is the probability of choosing a student given that person bought a sweatshirt? That's what it means. What is the probability that the person picked is a student if you know that that person is purchased a sweatshirt? Good. So how many of the sweatshirt owners were students? So 24 out of 32. So this little line here means given. And anytime you're dealing with a given problem, you only focus on that row or that column. Sorry, that row and that column. So what if I asked, what is the probability of t-shirt given parent? What is the probability that you randomly pick a person who bought a t-shirt given that you know that that person is a parent? 18 out of 26. So whatever is in the given section, that tells you which row or which column to look at. So in this case, parent is a row. So we're only allowed to look here. How many of those people were t-shirt purchasers? 18 out of 26. So that line means given, and it tells you which row or which column to look at. Okay? All right, here we have a Venn diagram. So we have 14 students. What is the probability of A, meaning that the person is in the chess club? So that would be 1, 2, 3, 4, 5, 6, 7, 8 out of 14. 8 out of 14. Right? Everybody in the chess club. All right? What is the probability of B? 1, 2, 3. So those and those, which is 7. 7 out of 14. Okay? What is the probability of A and B? How many people are in chess and science? 2 out of 14. Okay? What is the probability of A given B? So what does A given B mean in this case? Right. So we're only allowed to look at the B's. So we're only allowed to look at the science club. How many people in the science club are also in the chess club? 2 out of 7. So 2 out of 7. So that's what, and this is called conditional probability. A given B is called conditional. The condition is we're restricted to the science club. So 2 of the science club members are also in the chess club, 2 out of 7. And what is the probability of, oh geez. So that is saying we take the probability of B and we times it by the probability of A given B. Why would you do that? I don't know, but so that's saying if you pick 2 people, what is the probability that the first person is a science club member and the second person is in the chess club if you know that they're in the science club? So what is the probability that somebody is in the science club? 7 out of 14. What is the chance that the second person is in the chess club if you know that they're in the science club? That would be 2 out of 7, and you multiply those together. Okay? So let me go back to here and explain that one more time. So this says we're picking 2 people. The first person is in the science club. The second person is in the science. We want to know if they are in, how do we do this? The math club, if we know that they are also in the science club. The probability of A and B is going to be, it's that question right there. So what's the probability that a selected person is in both the science club and the math club? That's the same as the probability of science club and science club given math club, or math club given science club. That's a little bit beyond the scope of this class. Anyway, you guys won't be tested on those questions. All right. Okay. A coin is tossed 3 times. So one way to do that would be heads, tails, tails. So event A, of all possible outcomes, HHH, HHT, and so on, what is the probability that we alternate heads and tails? So how many of those alternate heads and tails? This one and this one. So 2 out of 8. What is the probability of getting exactly 2 tails? It would be 1, 2, 3 out of 8. What is the probability of alternating heads and tails and getting exactly 2 tails? There's only one way to do that, THT. Okay? Suppose the tosses are all... Oh, wait a minute. Oh, never mind. Suppose that the tosses are alternating heads and tails. From the remaining outcomes, find the chance of event B. So if I tell you I flipped this coin 3 times, and the result had alternating heads and tails, what is the chance that there are 2 tails? 1/2, right? So this is like saying, what is the probability of 2 T's given alternating H and T? Okay, this is conditional probability. So I flip the coins and I don't show you the results, but I tell you, oh, that's interesting. The heads and the tails alternate. By telling you that, I have eliminated all of these possibilities. Does that make sense? So if I tell you, the heads and tails are alternating, the only 2 possibilities are HTH and THT. So what is the chance that there are 2 T's? 1/2. Give the following probabilities and select. I don't want. I wish I could cut this part of the question out because I like the top half. Okay, so this is saying, what is the probability that A and B both happen divided by the probability of A? So we look up here. So A and B. What is the probability of alternating heads and tails and having 2 tails? 1 in 8. There's only one way to satisfy A and satisfy B. So if we go down here, the numerator is 1/8. Okay? And then we go back up. What is the probability of A? Well, it was 2/8. So what is 1/8 divided by 2/8? You flip the second fraction upside down, the 8's cancel, and I get 1/2. All right. Oh. Oh, I thought I took this one out. We're not doing dependent events. Okay. Here we have so we have a driver's education class. Some people took the class and some did not. Some people passed the test and some people failed. So let's finish out our 2A table. 69 and 24 is 93. 21 and 36 is 57. Add those together, and we get 150. 69 and 21 would be 90. And 24 and 36 would be 60. What is the probability of randomly selecting a person and that person passed the test? So we randomly pick a person and they pass the test. That would be all of the past test people, which is 57 over 150. What is the probability that the person passed the test given that they took the class? (36 out of 60). We're only allowed to look at the took the class row. Okay. Does it appear that taking the class helped you pass the test? So C is asking, is there evidence that a teenager who takes the class is more likely to pass the test than a randomly chosen teenager? So how many passed the class? We said it was 50, or passed the test, 57 out of 150, which is 38%. And if you took the class, the passage rate was 36 over 60, which was 60%. So does it appear that taking the class helps people pass the test? Yes. In fact, a better way to look at it would be this number here, 21 over 90, which is 23%. So only 23% of the people who did not take the class passed, and 60% of the people who did take the class passed. Oh, yeah. Okay, last one. It is estimated that during the past year, 26% of all students visited a therapist, and 40% of all adults used antidepressants. It is also estimated that 20% of all adults both visited a therapist and used an antidepressant during the year. So we need to set up a two-way table, and we need to figure out where to put the boxes. So we'll do antidepressants and no antidepressants. And we'll do therapy and no therapy. Okay. So what do we know about this box? Where should we put 26? (26% of all adults visited a therapist. Where does that go? Does it go in this box? So does it go in that box? No. It would be this one, the total. Right? So this is 26%, which means the one below it, this box has to be, well, everything adds up to 100%, right? So this has to be 74%, right? Okay. 43% of all adults used antidepressants. So this is 43, which means this one would be 57. Okay. It is also estimated that 21% of all adults went to a therapist and used antidepressants. So where does 21 go? Top left, right here, 21. Okay. Can I fill in the rest of the boxes? Yes, this one would have to be 5%, because 21 and 5 have to add to be 26. Okay. That box would have to be not 22, or 22, you're right. I'm sorry. 22. And this box would have to be 52, and it works in both directions, right? Okay. So now that we filled out the box, what is the probability that an adult visited a therapist given that he or she used antidepressants? So we're only allowed to look here. 21 out of 43. Okay. What is the probability that an adult selected visited a therapist during the past year also used antidepressants? That would be this row, 21 out of 26. Okay, let's do one more. All right. Of the drivers who stop at a gas station, 93 purchase gasoline, 6% purchase both gasoline and oil, and 9% purchase oil. So we build our table, and we do oil, no oil, and we do gas and no gas. Okay, where do we put 93%? Where does 93% go? Top right, 93. And I know this is 100, so if 93 goes there, then this must be 7. 93% buy gas, 7% do not. Okay. Where do I put the oil purchase? Bottom left, 9. And if that's 9, then this one would have to be 91. And 6% is gas and oil. So 6, and then we do 93 minus 6 is 87. 9 minus 6 is 3. 91 minus 87 is 4. And then 3 and 4 is 7. So we must have done it correctly. Now that we have the two-way table set up, what is the probability that a driver purchases gasoline given that he or she bought oil? So we know that that person bought oil, which puts us in this column. How many of those people bought gas? 6 out of 9. Okay. What is the probability that a driver purchases oil given that he or she did buy gas? So we're looking here. That would be 6 out of 93. So of all the people who bought gas, only 6 of them bought oil. 6 out of 93. Okay, that's it. Get to work.